Papaverine is synthesized in two steps. First of all, in first step, we synthesize homovirylamine. Second compound is homoveritryl chloride. So, first of all, we synthesize homoveritrylamine, homoveritrylamine, and then we synthesize homoveritryl chloride. For homoveritrylamine, we start with dimethyl catechol. Here, stated structure is dimethyl catechol. It is also known as 1,2-dimethoxybenzene. So, we start synthesis of homoveritrylamine from dimethyl catechol. This dimethyl catechol is treated with methanol in presence of hydrochloric acid. We get 4-chloromethyl 1,2-dimethoxybenzene. Here, in presence of hydrochloric acid and methanol, CH2Cl group is introduced and we get 4-chloromethyl 1,2-dimethoxybenzene. Here CH2Cl is introduced. Now this 4-chloromethyl 1,2-dimethoxybenzene is treated with potassium cyanide, KCN, potassium cyanide. So the chloride is replaced by cyanide group. Here CH2Cl is converted into CH2CN in presence of KCN, potassium cyanide, and we get 3,4-dimethoxyphenyl acetonitrile. CH2CN is acetonitrile. Now this 3,4-dimethoxyphenyl acetonitrile is treated with in one way with HCl, hydrochloric acid, and in second way it is treated with hydrogen and nickel, known as reduction. Here our compound number 1 and 2 both we synthesize from this 3,4-dimethoxyphenyl acetonitrile. So on reduction, first of all we see the reduction. Here our acetonitrile CH2CN group is converted into CH2NH2 on reduction. Here 4 moles of hydrogen is introduced and Cn is converted into CH2NH2. So after reduction we get 2,3,4-dimethoxyphenyl ethylamine or homoveritrylamine. It is our compound number 1. So on reduction of 3,4-dimethoxyphenyl acetonitrile gives homoveritrylamine. That is our compound number 1. Now we saw second route treated with hydrochloric acid, HCl. So 3,4-dimethoxyphenyl acetonitrile is converted into 3,4-dimethoxyphenyl acetic acid. Here see the Cn is converted into COOH. Cn is converted into COOH. So we get 3,4-dimethoxyphenyl acetic acid. Now this 3,4-dimethoxyphenyl acetic acid is treated with PCl5, phosphorus pentachloride, and then we get our compound number 2, homoveritol chloride. With interaction with PCl5, our COOH is converted into COCl. COOH is converted into COCl, and we get 3,4-dimethoxyphenyl acetyl chloride. It is known as homoveritol chloride. This is our compound number 2 for this synthesis. Now, compound number 1, homoveritrylamine, and compound number 2, homoveritol chloride, is condensed, and condensation takes place. So, here from hydrogen and here from chlorine. Removal of HCl. Homoveritrylamine and homoveritol chloride is treated as condensation. Heating takes place. So we get, after condensation, we get 2,3,4-dimethoxyphenyl and 2,3,4-dimethoxyphenyl ethyl acetamide. See the condensation. Chlorine from here and hydrogen from here. HCl is removed and condensation takes place. After this, these 2,3,4-dimethoxyphenyl and 2,3,4-dimethoxyphenyl ethyl acetamide is undergone dehydration. After dehydration, we get this compound 1,3,4-dimethoxybenzoyl 6,7-dimethoxy 3,4-dihydroisoquinoline. This 1,3,4-dimethoxybenzyl 6,7-dimethoxy 3,4-dihydroisoquinoline is treated at 200 degrees Celsius temperature in presence of palladium on asbestos. We get 1,3,4-dimethoxybenzyl 6,7-dimethoxy isoquinoline or papaverine. It is the synthetic compound papaverine. On this route, we get papaverine from our two compound homoveritrylamine and homoveritol chloride. Now, medicinal application of papaverine. Because of antispasmodic action papaverine on blood vessels, it has become extremely valuable for relieving the atrial spasm associated with acute vascular occlusion. It is useful in treatment of peripheral, coronary and pulmonary arterial occlusion. It is very important point. It is useful in treatment of peripheral, coronary and pulmonary systems. It is also used in relieving the spasm of the reproductive, urinary and circulatory systems. This is the very important medicinal application of papaverine. Here, our class of drugs antipasmodic is complete now. Now we studying about next group antihistamine drugs. Here is some mistake, not antipasmodic. It is not antipasmodic, but it is antihistamine drugs. Antihistamine drugs. In these drugs, first of all, we introduce this class and then we synthesize some antihistaminic agents. So, we start with introduction. Antihistamine drugs. First of all, we studied about histamine. The source of histamine in our body is decarboxylation of histidine, a naturally occurring amino acid. This amino acid in our body, histidine, and decarboxylation gives histamine. These are the structure of histidine and histamine. Histamine is found in all the organs and tissues of the human body in very small amounts. Histamine carries a wide variety of physiological response, that is, it affects almost every tissues of the body to some extent. Some of these physiological response are as follows. Number 1, it decreases blood pressure by dilating the capillaries and increase the heart rate. However, if it is present in excess quantity, it may cause an increase in the permeability of capillaries so that fluid and plasma proteins may escape into the extracellular fluid and lead to edema. Number 2, in the lungs, histamine has been found to act on smooth muscles, producing bronchiolar constriction. Number 3, in the gastrointestinal tract, histamine has a stimulating action on certain excretory glands, causing an increase in the secretion of the acid in the stomach, which may cause gastric and duodenal ulcers. Number 4, histamine stimulate the lacrimal, that is preparation of tears, lacrimal and secretory glands. Number 5, enough evidence is available which reveals the histamine play an important role in human allergy. It is the important point. Histamine play a part in the rapid growth of tissues, particularly after wounds. Now, we see about antihistaminic agents. Theoretically, the effect of histamine release can be overcome. Number 1, chemically, in which histamine is inactivated by using certain compounds like formaldehyde, carbon dioxide, enzyme histaminase. These compounds combine with histamines. Number 2, by substrate competition method, in which the compound act as a substrate competitor, thus preventing histamine from reaching the sensitive receptor tissues. And number 3, indirectly by initiating certain pharmacological response in the body which oppose the action of histamine. From above, it follows that antihistamines neither combine with histamine to neutralize its action, nor do they activate any enzyme which catalyzes the breakdown of histamine. It is probable that the histaminase usually act through competition in the tissues between the agent and histamine. It undergoes a combination with the receptive substance first before histamine can produce its effect on tissue. Thus, an antihistaminic agent may be divided as follows. It is a drug which capable of diminishing or preventing several of pharmacological effect of histamine, and which does so by a mechanism other than the production of pharmacological response diametrically opposed to those produced by histamine. Most of the active histaminic agent may be represented by the following general formula. This is the general formula, and in this formula X represents nitrogen, oxygen or carbon containing the side chain to the nucleus. Although the chemical structure of these drugs vary greatly, yet they exert similar pharmacologic and therapeutic actions. This is the general formula for the antihistaminic agents. It is interesting to note that antihistaminic drugs are able to treat symptoms of some arise and in no way change the fundamental case of allergy. They must be used as long as exposed to allergen parasites. Antihistaminic drugs are quite beneficial in seasonal hay fever. They are also used to relieve serum sickness, urticaria, an allergic condition marked with pinkish eruption with itching sensation, motion sickness, and nausea of pregnancy. Antihistaminic agents, in conjunction with analgesic agents, are widely used in the treatment of common cold. Antihistaminic agent shows many undesirable side effects which vary with the individual drug and the individual patients. Many antihistaminic agents are somewhat depressant to the central nervous system and cause sedation, leading to drowsiness, dizziness, and dryness of mouth, nose, and throat. Other undesirable side effects include muscular weakness, gastric irritation, loss of appetite, diarrhea, palpitation, and nervousness. In some cases, the side effect can be overcome by using a different antihistaminic agents. Cases of Benadryl. Benadryl is synthesize in two steps. So, first of all, we synthesize 2-methyl-aminoethanol. 2-methyl-aminoethanol. This is compound number 1 for this synthesis. And we synthesize second compound, that is benzhydryl bromide. Benzhydryl bromide. And then this compound 1 and 2 on condensation gives Benadryl. So, for synthesis of Benadryl, first of all, we synthesize 2-methyl-aminoethanol, and for 2-methyl-aminoethanol, we have starting material ethylene oxide and dimethylamine. Here described structures are ethylene oxide and dimethylamine. This ethylene oxide and dimethylamine are treated to give 2-dimethylaminoethanol. This is compound number 1. So, this reaction gives 2-methyl-aminoethanol. For Benadryl, this is compound number 1. Now we synthesize our second compound, benzhydryl bromide. For benzhydryl bromide, we have starting material diphenyl methane. Diphenyl methane. Here stated structure is diphenyl methane. Now this diphenyl methane is undergone by bromination. Bromination. It takes place at 130 degrees Celsius. Please note that temperature must be required. 130 degrees Celsius, diphenyl methane and bromine reacted and gives our compound number 2, benzhydryl bromide. Benzhydryl bromide. Here bromine, see in reaction, bromine introduce and substitution of this hydrogen, bromine introduce in diphenyl methane, and then we get benzhydryl bromide. This is compound number 2. Now compound number 1, that is 2-methyl-aminoethanol, and compound number 2, benzhydryl bromide, undergone by condensation reaction. After condensation, we get our final product Benadryl. Chemically, it is 2-diphenyl methoxy NN dimethyl ethylamine. I repeat the name. Chemically, Benadryl is 2-diphenyl methoxy NN dimethyl ethylamine. This is our final product Benadryl. Now, medicinal application of Benadryl. Benadryl is used as an antihistamine for the treatment of various allergic conditions. Today, Benadryl is well-known allergic medicine in market. So it is, or its important medicinal application is in use for allergic conditions. Number 2, it is also used as antispasmodic drug, also in antispasmodic. Number 3, it is used in the treatment of urticarial hay fever, bronchial asthma, etc. Number 4. It is also used in some cough mixtures. We discuss in first point, most of allergic cough syrup contains Benadryl. Next application, its most common side effect is drowsiness. It is noted that drowsiness is the side effect of Benadryl. It is used as hydrochloride and be given orally or intravenously. This is the medicinal application. So we here complete synthesis and medicinal application of Benadryl. Now we synthesize our second compound, that is avil. It is also known as trementon, avil or trementon. Avil is synthesized from phenyl 4-pyridine methane. Here stated structure is phenyl 4-pyridine methane. This phenyl 4-pyridine methane is undergone by bromination reaction. So after reaction we get 4 bromophenyl methane pyridine. We see here in reaction this hydrogen is substituted by bromine. So we get 4 bromophenyl methane pyridine. Now this 4-bromophenyl methane pyridine is reacted with ethyl dimethylamine. Ethyl dimethylamine. Here structure stated is ethyl dimethylamine. And after reaction, completion of reaction, we get avil or trementon. And chemically, avil or trementon is dimethyl 3-phenyl 3-pyridine 4-vinyl propylamine. I repeat the name, dimethyl 3-phenyl 3-pyridine 4-Y-propylamine. It is known as trementon, and trade name or market name of this compound is avil. Avil is also well known allergic medicine today. Now, uses or medicinal application of avil. These are the most powerful antihistamine drugs among the drugs known so far. It is very important. It is most powerful antihistamine drugs. And number 2, their action has also been found to be very persistent. That is a particular advantage in drugs of this type. This is also very important. I repeat the second application. Their actions also has been found to be very persistent. That is a particular advantage in drugs of this type. Here we complete the synthesis and medicinal application of avil or trementon. Thank you.